Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this lecture series, let us see about data converters and its type. So in the first video, let us see about analog to digital converter. So before going into analog to digital converter, we need to know about what is analog signal and what is digital signal. So analog signal is a signal that is continuous in time and amplitude as shown here. So it is a time varying signal that has any number of values or say variations for a given time slot. So next one is digital signal. So this digital signal is continuous in amplitude, but it is discrete in time period. So there will be a sudden change from one value to the other as shown here, where it suddenly changes from 0 to 1 and 1 to 0. So it has only finite number of values for a given time slot. So those electronic circuits which deal with analog signals are called as analog circuits, and those that deal with digital signals are called as digital circuits. Next, we will see what is a data converter. So, data converter is a device that converts analog signal into digital signal or digital signal into analog signal. So, in general, we can say that data converters are the devices which changes one form of a signal into another form of a signal. So, first we'll see about analog to digital converter. So if you want to connect the output of an analog circuit to the input of a digital circuit, then we have to place a interfacing circuit between the analog and the digital circuit. So that interfacing circuit is known as the analog to digital converter. So it is a circuit that is used to convert the continuous time signal into a discrete digital signal. So we know that all the physical quantities which we measure, like say temperature, sound, flow, etc., are converted into an electrical or electronic signal, and it is generated in the form of an analog signal. But our processors work better with digital signals only. So we need to convert the analog signal into a digital signal. So there are huge applications of analog to digital converters in electronic circuitry, such as in telecommunication circuits, in automation circuits, in measurement circuits, etc. So this is a block diagram of an analog to digital converter. So first you'll be giving the input to an anti-aliasing filter, which is nothing but a low pass filter. So here it allows only the low frequency signals and it rejects the high frequency signals. So generally you'll be having noise in the recorded signal. So noise signals are usually high frequency signals. So these signals are eliminated using an anti-aliasing filter. So next operation is you are giving it to a sample circuit. So where a sampler takes the samples from the continuous analog signal according to its sampling frequency. So normally the sampling frequency should be the Nyquist rate, which is nothing but twice the maximum frequency of the signal. So the sampling frequency is set according to the requirement. Basically, this sampler converts the continuous time, continuous amplitude signal into a continuous amplitude discrete time signal. Okay, so the next one is the hold circuit. So the holding circuit does not convert anything, it just holds the samples generated by the sampler. It holds the first sample until it receives the next sample. Once the new sample is received, it will release the old sample to its next block. And the next stage is the quantization. So here the signal is which means that it converts the continuous amplitude discrete time signal into a discrete time discrete amplitude signal. It breaks or splits the samples into small parts. Next one is the storage and transmission. So where you'll be using an encoder circuit. So the encoder is a circuit that actually generates the digital signal into the binary form. So the output from the encoder is fed to the next circuit. So this is the end of analog to digital conversion. So the working principle of analog to digital converter is very, very simple. So first the input analog signal is fed to the sampler circuit. The sampler circuit takes the samples from the analog signal with respect to the discrete time with the help of the sample frequency. Now the samples are held for some time in the holding circuit. After the holding circuit, the quantizer signal is fed to the encoder circuit that actually generates the digital signal in the binary form. So you need to consider the many factors during this analog to digital conversion process. A very important factor is the resolution. So for an analog signal, this resolution is not a matter. On the other hand, for the digital signal, the maximum and minimum value it should be determined correctly. So when the amplitude is reached or crossed over a particular voltage level, it is to be considered as high, and when it is below that particular voltage level, it should be considered as low. But for an ideal digital signal, it has zero amplitude, which is represented as binary 0, and a maximum amplitude, it is represented as binary 1. So the main features of analog to digital conversion is that sample rate and the bit resolution. So sample rate of an analog to digital conversion is nothing but how fast an ADC can convert the signal from analog to digital. Bit resolution is also nothing but it is the how much accuracy can an analog to digital converter produce while converting the signal from analog to digital. Next one is we'll see about the advantages of analog to digital conversion. The first one is improved signal transmission. So the digital signals are more robust to noise and interference during the transmission compared to the analog signals, making ADC conversion essential for reliable communication. Next one is enhanced storage and processing. So here the digital data can be easily stored and processed using the digital devices and algorithms than the analog signals. So this is used in modern technologies. Next one is high data acquisition rates. So ADCs, especially the integrated circuits, can achieve high data acquisition rates even with multiplexed inputs, facilitating faster data acquisition from various sensors. And finally, the most important thing is noise reduction. Normally, when you process in the digital manner, it will be free from noise when compared to analog signals. So it incorporates the techniques like oversampling and noise shaping to reduce the noise and improve the signal quality. So hope you understood the analog to digital conversion. Let us take up some assessment questions. First one is which of the following represents the range of frequencies measured by the ADC? And the answer is bandwidth. Next one, typical conversation speed of an ADC is less than 100 microseconds. Dynamic range of ADC is dependent on all the three, which is resolution, linearity, and accuracy. Thank you for watching this video.